said she's missing one of these, like one of you scoundrels took it home, or have it in your backpack, or something to that effect. So if I don't be careful where I put it, she'll be missing two. I'm trying to figure out where I'm gonna put this one. So if y'all could check your backpacks or whatnot, she asked me kindly to make that public service announcement of somebody find her missing one, please. All right. No names yet. I don't know if that's like investigation number 2. She tried to find the names, but yeah. Where was that? That's that one. Okay. Lab 13 with the mock-up boards. This is just for your info. I might have gave a bunch of people that had wrong answers right answers because, well, basically fault number 9 on the board I finished making. I might have put the fault in the wrong wire, is what it comes down to. So then I tried to give those guys the right grade, and I went through, and then I realized I actually corrected some people's wrong answers for fault 8, and I was like, no, I'm just all confused. So confused myself. So if you see correct answers that shouldn't be correct, don't complain. You got a bonus. But I think I have them, the boards at least corrected now. So if you do the labs, the boards should be correct. So FYI, if you're looking at it, you know, just be careful. But I gave you notes as well. All right. The Molex area yesterday, I was like this close to marking down everybody that made a Molex connection yesterday with a 1 for cleanup. But I didn't take good enough notes to see who made a Molex yesterday. There were parts all over the table, the tools were scattered, there were wires, it was a disaster. You guys did terrible. So if you could do a little better job of cleaning up after yourself and not using the excuse of, that's how I found it. Now, our latecomer helped me clean up yesterday, so he gets a gold star for helping me clean up. Not quite a free ice cream yet. Monday maybe. But just be aware of that, clean up after yourself and don't use the excuse, that's how I found it. We want to get in the habit of cleaning up after ourselves. Job and Zach, I think, were the only 2 on my list for, they turned in their battery box, but did not show me the battery box after they painted it.
Yeah, I realized.
Oh. Did you show anybody your painted battery box?
I have it right here.
So that's a double no. Turn in, okay. So show me during lab time, and we'll circle that.
Painted or clean?
I think it was painted, so like they submitted the lab, but I didn't have any of the instructors that physically checked after you painted it, right?
So I submitted my lab.
So, all right, just checking. Sometimes it's me where I'm like, oh, I didn't mark you down. I'm trying to stay more on top of this because as an instructor, if you put yourself in my boots, it can get kind of easy for people to be like, yeah, I did it, remember? I'm like, oh, no. And then you just start marking a bunch of stuff down and grading it, and see, Geese is going to be like, I didn't show you mine either, and you graded it.
I just submitted it like.
Oh, see, I should have put him on the list.
But because it was the battery box inspection, I thought. Not
Yeah,
the box
Geese,
itself.
so, hey,
Put me on your list.
way to fess up.
Okay.
Chatter?
I submitted my best stuff.
I think the instructions could be a little bit clearer.
It's what I'm thinking of. Well, no, we just didn't read half the instructions.
So I submitted
That's our
mine.
fault.
That's part of why I put it on the announcement today, is it's a little bit, so I'm trying to,
Which lab is it that?
the problem is there's like 3 parts, right? You've got the show it clean, show it painted, but also you talk through the battery box and battery with me or an instructor, so. So anyway, just make sure you show it to me, even if I already graded it, please come show it to me so I can mark you up or mark you down. We'll see how that goes. Trying to stay on top of it and be fair with grading without just going nuts as well. Stay out of the paint booth for a little while. So if you're painting them, there's tables set out in the lab for your acid-proof paint. That stuff doesn't have too noxious fumes on it. Something about, I think there's an aileron or a flap from the LLC that they're actually painting in the paint booth. So we're trying to keep that without dust and a bunch of people just stay out of the paint booth for a couple days, because it's being used for important stuff. Acid-proof paint, not so.
Education's important.
It is, but not with acid-proof paint. You could do that in the aircraft if you needed to. We're not so concerned with the finish, as it were. So concerned with the finish. And my last cleanup one is, we are starting to get where, like, for instance, on the ringing the terminals, there's only 2 boards, you need to do both of them for your lab, and there's 30 of you, right? I would highly suggest, if somebody hasn't done it yet, grab one of these work in progress sheets that hangs by the tool crib, and put it on a clipboard and put it right by them. Put a list, and hey, I'd like to be next. What would be convenient and handy is when you're done with it, you go hand the clipboard and the project to that next person. Now, if you're the next person and you're not ready for it, don't just set it in your cubby and say, I'll get to it tomorrow. Cross yourself off the list and go to the next person if you would, or at least tell them. That's gonna be the best way at SMAT we have to keep things moving through and make sure you get it done when we have to share some resources like that. So I'd highly recommend that for the ringing. But same thing, if you're working on a battery and lab time's done, and you're not completely installed, make sure you're using those job status or turnovers to say, hey, I'm working on this project, don't come in here and start because I'm in the middle of it, right? That's what I put those up there for last year, and if we use them, it keeps us all relationally happy because you know somebody's in the middle of it, or they're not, or hey, I'd like to be next. So please, go ahead and use them.
Is ringing the terminals the same?
Yes, we call that ringing the terminals because our ohm meters go beep when you find the right one. It's not much of a ring. It'd be more fun if the ohm meter was like then it'd really be ringing the terminals. So, you know, that would be more fun. All right, questions, comments before we get into the lecture side from all those, how labs are going. There is that alternator mock-up board that some people are poking at. Monday is the lecture on that thing. I'll actually, I think, have it in here if I'm not mistaken and go through how it works. So back to if you're feeling adventurous and you want to deal with it, you're welcome to peek at it. If you're like, hey, how does this thing work? Wait till Monday. Because we will cover it. Friday, tomorrow's Friday, we will be going over voltage regulators. Actually, I'm going to give you a little taste of them today. So we're getting there. We're working through all these, but we're also trying to give you lab time too. Just bad timing with your dad's hand. Because I heard a story from that same doctor, that somebody that went in before him, and after the surgery, he asked the doctor, he's like, am I still going to be able to drive with this hand? They had to cut 3 of his fingers off. This guy is a sheet metal thing, it was bad news. So he only had basically 2 left. And the doctor was like, yeah, but I wouldn't count on it.
Yeah, I'll have to go tell my dad.
No!
Kate doesn't want to get lost.
I like dark jokes. Just, that was bad timing. Yeah, but I wouldn't count it. To me, the side of yeah, but I wouldn't, sorry, if I gotta explain it, that's all right. Here are our fuel sensors into the actual lecture. This is your common one. I passed this around the room the other day. I'm gonna pass it around now, and hopefully it's not too distracting for you after I show you on the board. So this is kind of fun. I got a voltmeter here. Technically, this is an ohm meter, I guess. I have a multimeter, and I've got it wired in, one to the terminal on here, and the other one just to the ground frame. How it would be screwed in. This would typically be mounted with the letters, you know, you can't see the letters, with the letters up, so basically like that. And if it's out of fuel, there's very little resistance on that adjustable resistor, right? 0.5 ohms. As the fuel tank fills up, the resistance changes, and we go to a higher resistance. So, pretty cool. So, just for the fun of that, I'm going to pass that around for you, so you can play with it on your own, because it's fun to version of how we're gonna do fuel sensing. Now, yes, Mr. Ward?
If you have such a low resistance, doesn't that create incredibly high load on the?
We'll get to it in the next slide. Yeah. So, other than if you get a little bit older and you get two of the other style fuel sensors, one of them is a clear tube coming out of the tank and back into the tank, so you're sitting in the cockpit and you're literally looking at the fuel like in a little glass tube, and you're like, hey, now I don't even need a sensor, I can just see the fuel level. That's a fun one. There's another one that's similar, that the fuel tank sits right in front of the windshield. And in the fuel tank, they've got a little float and a wire that comes up, and it's on like a bobber, so that when there's fuel in the tank, the little wire's like floating up in front of your face, and when you're out of fuel, well, the wire's down in the tank. That's another scary one. So instead of those scary ones, we decided to use electronic stuff, because, you know, it seems more high-tech. But basically, right after those two, this is kind of the way to tell if we have fuel in our tank. Joe?
I was just gonna say, I flew one of those like a couple weeks ago.
Yeah, is that Cub or what?
It's Cub.
Yeah, Cubs have those, right?
It was really cool. When it stops bobbing, you got 20 minutes.
It's kind of similar to a Cessna. Like, you look over at the gauge, if it's moving, you're like, well, I mean, it's got to be accurate empty. So I know if it's moving, well, there's something in there, right?
It sits up like just above the windshield line, and then after like 2 hours worth of patterns, it's like about 2 inches above the bottom.
So if you have fuel anxiety type things, you're literally like watching your fuel go down. If I was better with PowerPoints, you'd make like a cross-eyed guy. Like, all right. So anyway, this is the common one on Cessnas for sure, but almost all the kinds of older aircraft. So, Mr. Ward, to answer your question, here is our wiring diagram. Basically, they're going to use the word instrument bus, but that's our bus right here with a 10 amp circuit breaker. So the power comes out of our circuit breaker, and it goes to a couple places. Basically, that's always the full, I think it's 12 volts on this system, 12 volts. And then it has 3 different devices that it can go through that are in parallel, right? One of them we're not dealing with is our cylinder head temperature. So one way for the electricity is to go through that sensor, and that would actually go out to a thermistor. Let's see, variable, how do you phrase that? Gotta draw a thermistor. That would go out to a thermistor for our cylinder head temperature. But our fuel level for our right-hand tank and our left-hand tank, it just goes through the gauge and then through what you're holding there, 3 and 3, is the transmitter for fuel level. So, the question of, wow, if it's 0 resistance, what's that going to do? So there's a small resistor, if you will, in the instrument, or a resistor. So if my fuel tank is full, and that's low resistance, we're going to have the highest amp draw, and the highest amp draw is going to tell our little amp meter in the device to say, go all the way to the right, you have a full tank. If our fuel level is low or empty, I'm saying this right for whoever's holding that, right? If our fuel tank is low or empty, the resistance goes up, which means higher resistance, lower amp draw. So our indicator dial is going to go to the left and say, hey, you're out of fuel. So pretty simple design. The end of that one, or the base of it, is just grounded, right? So it's completing the path to ground through the resistor inside there. So that's one of the other reasons. As it gets empty, it's not like we're worried about anything shorting out to ground when it's empty, because the fuel's above there. It's just a higher resistance. So they work pretty good. That is the fuel system that we've used for half a century. Kind of fun. The wires are pretty small, so I won't ask you too many other complicated wiring questions.
Is that like string that we're looking at, that's modified cut, or is that how that is?
I think that's not sealed, it does sit, it's not a, like, fuel proof. That thing is covered in fuel, yeah. So, kinda wild. Now,
I don't like that.
if you are flying the airplane and that's sitting like right next to your cockpit and you're what we would call skidding around the corner, so the airplane's not coordinated, but it's like throwing you to the side of your seat, and all the fuel goes to the outside of the wing, you might have a bunch of fuel in your tank, but that thing's gonna say, hey, I'm out of fuel, because there's nothing by me. So, they can be where they move around. I have fuel, I don't have fuel based on how you're flying. We have this style in our 206, the Samaritan 206, and if I take off and I'm not very coordinated and one wing's a little lower than the other, all of a sudden I get a little yellow light flashing on the dash, or a red light if I haven't filled the tanks, and it's like, hey, you're out of fuel, and I'm like, it's fine, I'm just not flying coordinated. So they are susceptible to where the fuel is sloshing around. The other thing is, technically, if you're doing inspections on these, they're supposed to read accurately empty. The important part is empty. And Cessna gauges are notorious for not being correct when they're full. They'll be 3/4, they'll be 7/8, they'll be somewhere around full. But there's not an adjustment on most of these for full. If you follow the airframe manual, there is an adjustment, I believe, on some of them for empty. So you gotta make sure it's correct on empty. The rest of it is just, yeah, you got fuel.
How often is the empty accuracy checked?
I'm not 100% sure, but I believe on the annual, or the 100-hour, they will do, you know, I'm not 100% sure, because we don't drain the fuel every 100-hour. So I don't know if it's just as complained about situation. Might just be a as complained about. As I think through it, I'm like, yeah, they're not draining the fuel on every one, but they do occasionally. It might even depend on if it's just a Part 91 or if it's a Part, what's the other one? 135. 135 means somebody's paying for the plane. The standards are a little bit higher. So I'm not 100% sure. Be a good one to dig into the manual or FARS for you, or ask an IA. Alright, so here's the other ones. I put a whole pile up because I was like, yeah, we want to show you these again. But the capacitance type, some of these are pretty cool. Like this one, I'm like, man, that is not a Cessna 172. That's a really thick wing. Where in the world are we getting these things from? I don't even think the King Air has a wing that thick, does it? That's a big airplane. So the capacitance type, we already tested one. Probably next year I won't test it. Last lecture, remember I put it in a thing up here and I was trying to test it for the capacitance to show you how it works. So I have my little picture up and I reminded you that 2 wires connected to each other. I was finding we're somewhere in the neighborhood of 30 picofarads. So you gotta be careful if you're testing them not to test it with your things connected. We're never gonna ask you to test them, I don't think. That one lab you only test the small capacitors, right, Tiki? They don't ask you to test the fuel capacitor. That's just thrown in there for a bonus. So they're very low. So we're gonna talk a little bit about the dielectric value of air for when it's empty versus avgas for when it's full. That's the next slide coming up. I did a bunch of research on this one because it was kind of fun searching into it. Dry air apparently matters if it's wet. Dry air is 1. That is what we compare everything to on dielectric. Now, dielectric, basically it's 2 things, right? And I'm not going to get crazy deep into the difference between the two, but it's got to be somewhat of an insulator, because if it was just a copper wire between them, you wouldn't have any capacitance, because, you know, the electrons would just go. So there's that piece of, well, it's got to be somewhat of an insulator, but the other part is how well does it hold that static charge. So with that said, the ones where we go down to water is kind of a weird. I think the number gets thrown off a little bit, because it makes it look like water is an incredibly good dielectric. Also, water, if there's any contaminants, are a conductor, so I like to throw the water one out. If you go really, really deep into this, they will use these capacitance type checkers for checking, what's the word I was looking for? It's in like city water tanks and stuff like that. But they'll check the salinity of the water with a very similar device, because as the salinity goes up, it changes the capacitance of the water. So when you're finding charts that give you a dielectric number for water, the only reason they're doing that is you can actually use kind of the same device to say, hey, how much salt is in this water based on how much did that dielectric value change, what capacitance changes on water that's pure versus salt water. So kind of interesting.
It increases with increasing salinity, I believe.
I can't remember for sure, but that sounds right, yeah. So most fuels though are way down here in the 1.7 to 2.8 range. Did I have that? This one had water, but ethanol, isopropyl alcohol, they got a lot of water in them. So anyway, liquid paraffin is in the 2, so we're at a real low number, but it's above 1, right? So our instruments that are sensing how much fuel is in there that we can calibrate, they can tell the difference between avgas and air, and we can adjust them accordingly. I've heard water in your fuel will really throw the numbers up. Also heard airplanes don't fly very well with water in their fuel, so really the key is get the water out of the fuel before you go flying, and you won't have bad numbers. Just, yeah, there's that. So I threw in one other image down here. This is a picture of a wing system, and all those little colors are actually capacitance type fuel level checkers. So in your Cessna, you might only have 2 floats, 1 for each tank, but as the aircraft get bigger, number 1, you might have bigger fuel tanks, but actually what they got is, I think on this one, they've got 1 fuel tank here, 1 fuel tank here, 1 fuel tank here, but multiple probes in each fuel tank. So you might have, I mean, that picture's got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's got 30 fuel sensors. That's a lot of them. So they'll do some averaging and stuff, but pretty cool way they do it. Typically, these capacitance ones, there's an adjustment. Sometimes it's on the box like we talked about, that's somewhere else. And you're gonna have a full adjustment, and you're gonna have an empty adjustment, you're gonna calibrate them in. You are gonna follow the maintenance manual. I said this once, I'd like to say it again, and I'll say it again at some point. You don't just walk up to the airplane that's empty and be like, oh, it's empty. Well, let me switch it to empty. You absolutely follow the maintenance manual and the procedure for doing it. But the concept is pretty simple. You're gonna adjust the empty one when the tank's empty, you're gonna adjust the full one when it's full. But some of them are a separate device. Some of them, they're built right into the head of the sensor here. So like this one's built right in, kinda cool, it's just a one piece. They made it easy, or made it expensive. I'm not sure what the plan was, maybe a little bit of both. Everybody likes easy and expensive. Alright, one thing that a prepware question likes to ask is, they'll say the controller, or the instrument, I should say, will use a reference capacitor. This one doesn't have it built in here, so it must be in the gauge in the cockpit. But the idea is going to be, it's going to have a capacitor that's typically the same as empty, if I can phrase it that way. Maybe it's the same as full. Either way, depending on how they design it. So the instrument's going to look at, hey, what's the capacitance of my fuel? and I'm gonna compare that to a reference capacitor that doesn't change capacitance, and it's gonna say, are they the same? If they're the same, I'll give you this needle setting. If one's lower, I'll give you this needle setting. So in these, and it's a prepware question, on some system somewhere that they picked out, which is it's the more common way to do it, but I would hesitate to say everyone everywhere uses a reference capacitor. But let's say, I'll get to you in a minute, let's say ours is 30 picofarads. Your reference capacitor might be 30 picofarads, maybe it's 10 picofarads, but they're just gonna say, hey, how much different is it? And then I'm gonna move my needle accordingly to tell you how much fuel's in the tank. So when you see that question on a reference capacitor, that's what it's doing. All right, back to Shane first.
So on the beach jet, we ran it a few, 5, 6 weeks ago. We're having trouble with the fuel sensor. The left one's solid, but the right one was alternating, indicating almost empty and indicating like almost full. And even yesterday, we didn't fire it up. We just connected the battery and had no intention to take off.
Power to go.
Well, I desire to take off, but I had no intention to. And so I noticed yesterday, the left tank's holding solid at, 200 gallons, but the right one is just bouncing, just permanently just bouncing up and down.
Yeah.
Could that be related to some sort of we'd have to trace it, but some sort of a fault electrically
Oh, yeah.
with the sensor saying, I'm full, no I'm not, I'm full, or like one guy's saying he's full, other guy's saying it's empty, up and down, up and down.
So it's more likely, I'm gonna use the word either an electrical connection somewhere, or maybe even your reference capacitor connection. Because, there's not a whole lot to, I'm gonna use the word go bad here, right? Two tubes, like what's gonna go bad? So what's gonna go bad typically is a connection. So we're gonna have, and maybe it's the wire connection at the top here, maybe it's your wire attached to it, maybe it's the wire somewhere between here and where it connects to this, maybe it's one of the wire connections in here. So yeah, that's a pretty tricky way to do it. A lot of times for troubleshooting, A, you're gonna follow the manual, but B, a lot of times for troubleshooting on something like that, they'll just start doing part swapping. They'll have a good component, so if you know the left system's running right, they'll be like, all right, I'm gonna move this fuel sensor. Nope, problem's still there. Let me move the module. Nope, problem's still there. Sometimes the service instructions will actually tell you to do that. That is what we do. I passed it around. On the Cessna one, if we want to know, hey, is it the float, sending unit, or is it the instrument, or somewhere between? A lot of times what the mechanics will do is they'll just go behind the panel and they'll switch the two wires and say, hey, does it still read right, or did it switch sides? They'll figure it out. So for instance, I'll go back, I'll slow that one down. Let's say you got your Cessna, I got one wing tank, I got another wing tank, I got an instrument for both. If my right gauge is not working correctly, and we're like, hey, is it the gauge or is it the sensor? They'll hook up the sensor from the left one to the right one. If it starts working correctly, we go, okay, the problem's out here or the wiring somewhere, right? So sometimes the manuals will actually have you do that, because otherwise, a lot of times what's left is inspect the electrical connections. Like, wait, really? That's all you got for me? But how else do you tell you to inspect electrical connections? Possibly ring out the wires is the word they'll use, kind of like you're doing on these little one plug. But you'll have somebody out in the wing, and they'll, with a voltmeter or ohmmeter or jumper wire, short to ground, from the wire you got the plug, and the other guy's on the other end. Yep, that one's connected. Yep, and it's a hassle. It's no fun. Cheddar.
Yeah, with Garmin systems, you have to calculate fuels compared to your fuel sensors. Is there anything like that that exists with older aircraft?
Calculate. Say that one more time.
Where you put in your fuel,
Okay.
and then that's comparing with what your sensors are telling you.
All right, so when you say Garmin systems, on a lot of our aircraft, we will tell the aircraft how much fuel we put in. And you guys will learn about the transducer later. That's a little wheel that basically spins. And there's a couple different styles, but the easy version is there's a little wheel that spins and is very accurate. So if you put in 50 gallons and then that little wheel spins, the computer will tell you, you have 20 gallons a system that's not actually measuring fuel depth. It's just, so basically you got two different systems going on, and you can say, hey, which one do I trust? So I think your question is that common? And yeah, new aircraft, almost everybody has a fuel transducer. Transducer means we change either pressure or flow into electrical signal.
Yes, I'm wondering if there's a different component that does the same thing that existed before in the solid state.
For solid state, I'm not sure. I'm not sure. Alright. Okay. I found these, part of it was there were some prepware questions that were asking about different styles of fuel sensing, and I'm like, oh, FAA doesn't really teach us much about anything else. They'll teach us the resistance type, and they will teach us the capacitor type that has a reference capacitor, but they don't give us much else. Some of the questions do kind of pop up. Ultrasonic fuel level is, apparently they're using noise to like bounce off, and however long it takes the noise to get back. I don't know exactly how it works, but I'm just telling you, it's a thing, it's out there.
So is that why I get a different fuel reading when I'm like full power versus pulled back to idle?
That's just because you tipped your airplane. That's because you tipped it. LiDAR is a radar, right? It's like a light radar, something. I don't know exactly, but I'm not going to tell you how it works. I'm just going to tell you it's a thing, it's out there. It might be in an aircraft you run across, and you'll be like, what's that? That's not a capacitor. Case never taught me about that. I'm like, yeah, it's because he didn't know what it was. But it's there. And an actual radar one, which is crazy, right? So they do have newer ways of figuring out how much fuel's in there. The capacitance type is still the most common, but people are coming up with other ways. Part of it is, as we get fancy with electronics, these don't weigh very much, right? Just a little computer sitting on top of the tank. And how many of these did I say we had in that one picture? Like 30 of them. So this is, I don't know, a couple pounds. So we saved like 50 pounds or whatever by going to the other. And they might be more accurate because we're not chasing connections down. So anyway, there are new and improved ways of measuring fuel. We're not covering all of them in here. Those are back to the main two. Okay, I'm going to hit briefly what we're going to talk about tomorrow. And then tomorrow we're going to go over this for an hour and a half. So today is just to hopefully put some words and some terms into your mind, so that when we go over it tomorrow, you don't leave and go, I'll never understand those things, they're too complicated. Because they're really not that complicated. Basically, there's 7 different functions inside here, if I can phrase it that way, that will control our generator output. You could use this on an alternator, but we'll learn why we don't. So back to a generator on an aircraft. We have that generator that's spinning, usually tied with a belt to our engine. Sometimes they're geared right in, and we want to make electricity with it. Basically, we're going to want to vary the field strength in order to vary how much output we have coming out of our generator, right? What was very common for a lot of years are these 3 contact voltage regulators. On these 3 contact voltage regulators, and they can be built a couple different ways, but basically there are 2 sets of contacts that the field winding wire goes through, and if the contacts are closed, the field is getting full voltage or full power. Usually what that means is the positive goes through the field, and then it allows it to get back to ground. So if those are closed, the field will be putting out the maximum output that it can. What controls them is on one of them, we have, I gotta make sure I got my story straight. Point at it. Yeah, on one of them, we have set up so that if the voltage gets too high, says, hey, you better open that contact. Makes sense, right? Opens the contact, the field shuts off, now I'm not making power. Now these don't go click, 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 click. We call them vibrating points because they're like going really fast like that. So you can imagine if it's closed more often than it's open, the field's gonna be stronger. If it's open more often than it's closed, the field's gonna be weaker. So they go very, very fast. But basically, if the voltage gets high coming out of the generator, it opens the contacts to say, back off a little bit, buddy. The next one over on this is the amperage. So if our generator's rated at 50 amp output, and we get up to 51 amps, basically it's a big old wire going through it. At 51 amps, it's gonna say, too much, open up to reduce the output. So same kind of idea. So we've got an over voltage coil and contact. I got an over amperage coil and contact, so that we don't overdo it. And then the last one is a reverse current relay. We're gonna deal with that in more depth tomorrow. But basically, once the generator is running and producing voltage, it will close the contacts and connect it to our battery, so we start charging the battery. Once we're charging the battery, it stays closed, but if we ever pull the power back too far, or we put too much of a load on for something like that, but usually it's if we pull the power back too far and slow down the engine, and if our battery is now a higher voltage than what my generator is, because my generator can't keep up, the power would start going backwards and try to power the motor, and this contact will say, whoa, we're going backwards now, we better open back up. And it'll open up and shut everything off until it spins up and gets high enough voltage again to where it's bigger, and then it'll close. So we're gonna cover that more tomorrow, but just the intro today, we've got an over voltage relay, over amperage relay, and a reverse current relay built into them. So we'll deal with it more tomorrow, but that's the intro for today, so that when we introduce them tomorrow, you go, yeah, I kinda heard about that. One of the things is sometimes they're from, let's say, right to left. Sometimes they're from left to right. So you always want to look kind of close and see which two contacts are connected to each other, because that'll tell you those are the field controls, and then the reverse current one will be the one that's hanging out on its own. So these two are connected with that bar. So on this one, the field's on the left, reverse current's on the right. On this one, these two are connected, so the field's on the right, and the reverse current's on the left. But we're gonna go over that in way more detail tomorrow, but just want to give you a slight taste, because they're really kind of simple if you don't rush them. Okay, questions, comments on our fuel stuff today, or what we got going? Great.
Just real quick, those regulators would mostly be found on older aircraft, right? Because most of them went to alternators?
Correct. So for two reasons. We went to alternators, so you're only gonna see these if you have a generator.
Right.
And even on the ones that have generators, some of them went to solid state as well.
Okay.
And we'll talk about it tomorrow, but because of the contact points, they tended to be high maintenance, so most people got rid of them. But the FAA loves these questions on their tests, because if you can understand these, you can understand electrical, so they're like, all right, we'll test them on that, we'll see if they can understand electrical. Okay, dismissed. Don't forget to take a 10-minute break before you dive into your labs too deep. Oh, I heard, if you're in on the party, we got a party today, is it Thursday?
That's Friday.
Today's Thursday? Party at Culver's at lunch.
Yes.
It's not really a party, it's
Who's
just,
paying? It's on cases.
it's just a lot of random people have been showing up at Culver's on Friday because it's fun. So just give me a heads up, tomorrow, I think they have a little cake or something for Anna. Tomorrow. So we didn't wanna all be at, not all, we didn't wanna be at Culver's and skip Anna's little thing. So we were like, you know